So in this video we're going to look at logarithms. What is a logarithm? And specifically we're only going to look at natural logarithms. So here's an example to illustrate the idea. Suppose that when working with wounds to the skin, this function a equals a naught times e to the negative 0.11 t relates the area a of unhealed skin to the number t of days since the skin received the wound. So t days after the skin is wounded, the size of the wound is given by a, where a naught represents the initial area of the wound. Okay, so the size of the wound a depends on the initial area of the wound and the number of days since it happened. So suppose that somebody's skin receives a wound that is 2 square centimeters in area, and the number of square centimeters of unhealed skin remaining after 8 days is found by what? Okay, so a naught is equal to 2 because that's the initial size of the wound. So the number of square centimeters of unhealed skin after 8 days is given by a, where t is 8. I'm going to plug in 2 right there for a naught times e to the negative 0.11 times 2. So it equals 2 times e to the negative 0.22. And we're going to need a calculator to approximate that value. Okay, so we would push this in here. So we're going to do t2 times second ln for e to the negative 0.22. And that comes to approximately 1.605 square centimeters. So the area of the wound is about 1.605 centimeters squared after 8 days. So it starts out at 2 centimeters squared, and then after 8 days the size of the wound is down to 1.605. Okay, this has nothing to do with logarithms. But suppose instead that the question is asked the other way around. Suppose instead it's asked for a skin wound of 2 square centimeters, how many days will have to pass before only about 0.83 square centimeters of unhealed skin remain. Okay, so we're instead trying to find how many days. That means we want the value of t, okay, before the area A of the wound equals 0.83. Well, if we plug in into the model up here, 0.83 for A equals 2 times e to the negative 0.11 t. And we want to solve for that value of t. Well, you could make a little bit of progress, just by dividing by 2. So we can say 0.83 divided by 2 is 0.415. So where does 0.415 equal negative 0.11 e to the negative 0.11 t? Well, we don't have the techniques to solve that because the t is up there in the exponent. The only way to get the t out of the exponent and solve that equation is to use what is called a logarithm. It just gives us a way to access the exponent of an exponential function. Okay, so the natural logarithm is what we're going to focus on in this video. So in this equation, more generally, a equals e to the t, where a is a number. The number t used, that when used as an exponent on the base e, produces the number a is called the natural logarithm of a. So the number t is called the natural logarithm of a. So t is the exponent in the exponential equation. Okay? So therefore, the exponent is equal to the log, okay, which I'll write out in just a moment. So the words natural logarithm are usually abbreviated ln. Okay? But you can't actually just have ln, that's cursive ln, by itself. You have to have the natural log of something. So if a equals e to the t, as I have right there, if a equals e to the t, then t is the natural logarithm of a, is how you would write that in its abbreviated form. Or in equation form, you would say t equals, the expanded form is actually log base e of a, but most people just write it natural log of a. And the parentheses are not always used. It's commonly written ln of a, just like that. Okay, so in conclusion, t, the exponential equation here, is a equals e to the t, and the logarithmic equation, the corresponding logarithmic equation, is t equals the natural log of a. Okay, and you can go back and forth between these. So this is how you solve for the exponent in an exponential equation. So this is actually quite useful since exponential equations are so common. So a few notes here. The number a is called the argument of the natural logarithm. And that's because it is the input to the natural logarithm. It's what you're putting into the logarithm function. Since t is a logarithm, okay, right here t equals a logarithm, and it's also an exponent, that means that a logarithm is an exponent. Logarithms are exponents. Okay, so t equals the natural log of a if and only if a equals e to the t. So this equation goes both ways. You can convert from one direction to the other or vice versa. We know that e to the t is always a positive number from our study of exponential functions. So therefore, in a equals e to the t, a is always positive. And t equals natural log of a actually expresses t as a function of a. So the natural logarithm is in fact a function.